any database, we're typically recording facts about the real world in the database at some point after they occurred in the real world. Or if we're taking future orders or future instructions, or we're doing predictive and forecasting type analyses, we may actually be storing facts that we believe will be true at some point in the future. If I'm an airline and I want to forecast how many seats I'm going to sell on flight 999 departing on the 28th of July, I probably run that forecast 14 days ahead of the flight's departure, 7 days ahead of the flight's departure, and a day before the flight's departure. Again, we've got two time dimensions. The time dimension during which the flight will actually depart, and those time dimensions where I'm predicting how many seats I'll sell 14 days out, 7 days out, and 1 day out. Recognizing and understanding that difference between perception and reality turns out to be incredibly important for time-based queries in the data warehouse. So traditional SQL database technology that's based on the current ANSI SQL standard is pretty good at representing time instance, but provides only weak non-native support for representing time intervals, for helping us understand the duration of time for which a state was valid or something was true. The idea of upwards temporal compatibility is that we can convert existing tables to the new temporal representation without having to rewrite all of the existing applications which query the current state of the database. The temporal modifier that users provide that gives the DBMS an understanding of whether we're interested in the state of the database as it is currently, or at some point in the past, or at some point in the future. This can be provided at session level, and a current temporal query will return the same answer set that a current query does today. So existing applications don't need to be rewritten. The same SQL will continue to produce consistent results before and after objects have been converted to temporal representation. In Teradata 13, the last release of the Teradata DBMS, we introduced support for an encapsulated period data type and functions and operators to manipulate that type. That addresses this issue that we have in ANSI standard SQL and traditional SQL technologies of not having native support for an interval. That's necessary, but it's not sufficient. So in the latest release of the database, Teradata 13.10, shipping in the second half of this year, we will introduce support for automatic modification, or we'll introduce support for temporal tables and also for temporal queries. Now when we tell the DBMS that a table is a temporal table, it will automatically apply temporal semantics when we update that table. In a data warehouse, we put data into the database, but we also want to query the data. We also want to get data out of the database. So we also now support temporal queries. And temporal queries are much simpler to express in Teradata 13.10. So asking questions about the current state of the data as it was at some point in the past, the data as it was between 2 points in time, these have traditionally been extremely difficult to express in traditional SQL. In Teradata 13.10, these become trivial to express. And that means the power of understanding how the data has changed over time becomes available to a whole new group of end users in the organization.